Okay. So this is another supervised learning algorithm. So this is called the, decision tree. So from the previous lecture talk about instant base where they use the um, measurement of differences between the new unseen data to the k nearest sample that we have in our data set. Okay. Okay. So for decision tree, this is a model that construct a tree to determine the level of your new instant data that we have. So for example here, this is the uh, example in which we want to decide whether we want to accept the offer of job or we want to decline. Okay. So we're starting from here. Our decision say that if the salary is at least 50,000, then I go to here. If no, then I will reject. Then if yes, then I will test again. If the travel time is more than 1 hour, if yes, I will decline. If no, then I will ask for coffee. If there is a coffee, then I will accept. Okay. So this is the sample of decision tree. So during the modeling for this decision tree, they will construct the tree for us. Okay. So the leaf of the tree will be the label, and the root of the tree would be the first features that we use to test. Okay. So we will learn how to construct the tree. Okay. So for example, like this, we have x1 and x2 for our sample here. So we have class 1 and class 2. Okay. Class 1 and class 2. So for us to divide this space here, so we can say that as long as your x1 is greater than W10 and your x2 is greater than W20, they belong to the square red. Okay, otherwise they belong to the blue. So this is the first condition. Okay, x1 is greater than W10. If yes, then you check again if x2 is greater than W20. If yes, then they belong to the red square. And otherwise, they belong to the blue square. No, the blue circle. Yeah. So decision tree use the divide and conquer method in which they will split your data so that each partition will have single class majority. So for numerical value, we can use the value to split the data, or for the discrete one, we will have the n-way split for n possible value that we have in our features. We could also use the multivariate, which means that we use more than one column to be the condition. For example, like this is univariate. We can also use multivariate. So here the formula would be x1 greater than W10 and x2 greater than W20. So we have multivariate. So we test 2 in one node. Okay, that is multivariate. Okay, so the leaf of the tree will be the class label. um, remember last time we have the regression tree. So the splitting of your data um, re- will be at the position where we have the maximum reduction of your standard deviation. Okay, so we will use the greedy algorithm in which we find the best splitting of your data set. Okay, so the decision tree are built using a heuristic method called recursive partitioning. So we will keep partitioning our data until we have a subset in which we have majority of them or all of them belong to a single class. So we will stop splitting until you have all of the example at the node have same class or no remaining feature can be used to split or the tree has grown to a predefined size limit. So meaning that we have reached the maximum depth of your tree. Okay, so we all have learned about entropy. So entropy referring to the purity of your data set. So when we are here, entropy is 0. Okay, so and your positive sample is 0 also. Okay, um, so when we are at here, so that means your entropy is 1. That means you have half of your positive sample belong to no, half of your sample belong to positive sample and the other half belong to negative sample. When you are here, your entropy is 0, so very pure. So that means all of your sample belong to positive class here. When you are here, all of your sample belong to this is positive, this is negative. Okay. So the total entropy for your data set would be the combination of the positive and the negative here. So this one looks familiar in your previous lecture. Okay. So for example, like this, we have the data set that we have here. So we have 5/8 for A and 3/8 for the B. So this is the probability of A and this is the probability of B in our data set. Okay. So if we want to compute the entropy for this, basically we just plug in the value here. So we have A and B. Okay. So this is for the A and this is for the B. And we have 0.95. So very high entropy. That means our data set, our partition here is not pure. Okay. So if we apply the formula for our data set here, for example, okay, if I take outlook, I want to take this outlook, and then I want to split my data using this. So I have 1, 2, 3. Okay, 1, 2, 3. Okay, three unique value for my outlook. So the sunny will give me 3 no and 2 yes, and the overcast will give me 4 yes, and the rain will give me 3 yes and no. Okay, so for, so how do we decide which attribute we want to use for splitting. So for this one, I just test for outlook only. So we can do for temperature, humidity, and wind. Okay. But for the beginning, I just take outlook. Okay. So what happened here if I split my data in using outlook? Okay. So for the sunny, the the entropy is 0.96, and then for the overcast, the entropy is 0. Okay. And for the rain, the entropy is 0.9. How do I know 0.96? Because they are similar. 3 versus 2 and 2 versus 3. Okay. So this is the entropy I get for each subset after splitting. Okay. So what I want to know is, I want to know what is the um, before and after splitting. So this is before and this is after splitting. Then I can get the info again here. So for example, for this one, if I split these two into half, so this one will give me higher entropy. This one will give me zero entropy because they are pure. Okay. So this one is pure. This is a mix of um, the plus and the circle. So this is very impure. So that means your entropy is high. This is your entropy is the lowest, which is 0. Okay. So we will use this formula here, before and after. So this is the total entropy for the number of partition that we have. So this is the weightage for each of the partition. Okay, and this entropy can be calculated here using the formula that we have before. So let me proceed with the example again just now. So to apply for the info gain here, the entropy for before splitting would be um, this one, initial. Okay, so how do we get that one? The initial would be 1, 2, 3, 4, 5. So 5, this is for the no. So 5 over how many data we have? 3, 3, 4, 14. And we have 9 over 14. Okay. So we take the log 2, 9 over 14, plus 14 log 2. So this one will give you this value. Okay, so if you compute, so the initial entropy would be looking at the class here. So we get 0.94 here. So when we split our data, let me erase this one. So when we split our data here, we have done the partitioning. Okay, so we have 3 groups here. So we know that the entropy for this one is 0.96. This is 0.96. This is 0. And our initial here before we splitting is 0.94. Okay. So we want to total the entropy for this 3. So the formula is here. So this is the weightage for the first subset. This is the weightage for the third subset. This is the weightage for the second subset. Okay, so if we solve this calculation, we have dot 68. So this is after, and this is before. Okay, so the information gain would be calculated before and after. So we get 0.6. So the aim here is choosing which column that will maximize this. Okay. So in this example, we just show you what is the IG when we split the data using this column. Okay. So for decision tree, so it will not stop here. It will do this one again, and then this one again, and this one again. So they will choose the features that give you the highest information gain. That's how they choose what would be the root attribute in your decision tree. Okay. Okay, let's give you another example here. So this is another data set. Okay. So the initial entropy is 5. This is for the no. This is for the yes. Okay. So if we split them using the count here, so we are looking at A, B, C, and D. So we have for the A, we have 2, 2. So this is A. And then for the B, we have 2 no and 1 yes. So this is 2 no and 1 yes. And for the C, we have 3 yes. And then for the D, we have 1 and 1. Okay. So we solve this and find the IG. We do it again for here. But this time your partition will be different, which is, so now this is here and then here and then here. So we have 1, 2, 3, and 4 partition. So we repeat this one again and then find the IG. So at the end of the calculation, we say, okay, if the info gain for the count is greater than the info gain of the total, so I will choose the count to be the feature to split our data in the tree. Okay, so this is how we determine which feature is more important with respect to the class label. Okay, so let's have a look at the example here. So this is the application for the loan. So we will divide them into 5 steps. Okay, so the first one is we are reading the file. Okay, so I need to get the file in the right thingy. What is the name of this? Credits. So I go back to Okay, so I'm reading this. So I look at the structure of my data set. So basically, I have 17 variable, so 100 rows of data. So the cost label is this one. So um, highly to default means highly not to pay your loan. Okay, and the features that I have will be all here. Okay. So if we look at the value for the checking balance, so we have less than zero Dutch money. We have 274 number of rows. Greater than 200 Dutch money, 63. Between 1 and 200, I get 269 and I have unknown. So we have um, missing value here. If we look at the saving balance, okay, so these are the number of rows for each of the value for saving balance. Okay. And if we look at the loan duration, so we have maximum 72, minimum 4. So that is just to look at the, okay. So if you look at the label here, so that means 30% of your customer is highly to be defaulted, means not paying the loan. Okay, so based on this data, if we have a new sample data, we want to do the modeling so that we can decide whether the new applicant is highly to default or not pay the loan or not. Okay. So how do we build the model? Okay. So first we set the seed to 1 to 3. The reason why we put 1 to 3 is that in case if we want to repeat the experiment, because we are doing the sampling here, so 900 we take randomly from our 1000 data here to be in the training sample. Okay, so basically this is the ID number of your data set. So this is the 900 sample ID that we get from 1000. Okay. So I will take this and put in the training dataset. So I take this ID for the dataset here. I put in the training dataset, and the remaining I put in the testing. So you look at the minus here. That means I'm including all except this. So I put in the testing. So this is the 900 data. This is the 100 data that we have. Okay. So if you look at the proportion for the training and testing, so this is for the training. So we still maintain the uh, proportion for no and yes for the training data set. And this is for the testing data set. Okay. Okay, now we install the decision tree. They call it C 5.0. So we install this package C50, and then we upload into the memory, and then we can call the, okay. So we take the training data set here, not including the label, because we only take the um, independent features, and then this is the label, and we use the decision tree here. Okay. So if we look at the model that we have here, so this is basically the tree. Okay. Um, yes, but I need to look at the model tree here. We look at the summary. Okay, the summary here will tell you the structure of the tree here. Okay, so over here they say that if your checking balance is greater than 200 Dutch money or unknown, so that means you are not likely to be defaulted. That means you pay lah. But if your money is less than 0 or in between 1 and 2, and your credit history is perfect, so you are highly to default. Okay, so the number here saying that 412 correctly classified, 54 incorrectly classified. Okay, so so this is what we get. So if the checking account is unknown or greater than 200 Dutch money, then classify as not likely to default, means you will pay your loan. Otherwise, if the checking balance is less than 0 Dutch money or between 1 and 200 Dutch money, and the credit history is perfect or very good, um, you is you classify as likely to default. Okay, so based on this model, we can know the reason why uh, certain item is classified as positive or negative based on the tree that we have. So compared to deep learning is a black box, so you do not know why they decide positive or negative. Okay, so this is only the training. So what we want to do is we want to do the prediction here. So we do the prediction here. So this is the model that we have. This is the test data that we have. This is the one that we created here just now with 100 sample. So this is the output of our prediction. So okay, for the 100 sample data that we have. So we want to compare that one with this. With this one. Okay. So this is our actual label. This is our predicted label. Okay. So we want to compare these two. So we can compare that one. We can use the cross table here. So the cross label here is taking the test here and the predicted label here, and then we can plot them. So over here we have 20 plus 10 misclassification. Okay, so that means 30 so 30% error. Okay, so we can improve this one by having what we call it the boosting. So over here, so we are using decision tree, but we use trial meaning that we are building 10 trees. So this one will form a random forest tree. Okay. So this is the model that we have. And then if we do the prediction using this, it would improve your accuracy. Okay. So now, previously we have 20 plus 10. Now we have 17, 13. Okay. So still the same. What if we increase our test here to become 20? Okay. Still the same. So that means maybe different. Yeah, still the same. So maybe can do other things, but this one is different. We still have the same error here, but we we have different number of nil. What we call it, the sensitivity and specificity, the positive, um, the false negative and false positive. So that affect the performance of the classifier that we have. Okay. So in summary, the strategy each method employs to tackle the problem of partitioning data into interesting segment. So we look at here. So we first count the entropy and then compute the IG. Okay. So this is useful when you want to know the reason why certain sample is classified as positive or negative. Because we have the decision tree. So we can have a look at the decision tree and then we can analyze more why certain people or certain item is classified as positive or negative. Okay. Okay. Any specific question?